Welcome to our 427 group.
Hi, I'm Kira. I'm Sarah.
I'm Ashley.
And I'm Meg.
For our Knpe 427 group project, we decided to investigate the question, when cycling at 75% of VO2 peak, fatigue is delayed when you ingest a glucose solution as compared to just water. In order to develop our hypothesis, it is critical to identify the mass, inflow, and outflow in the system. We have decided to identify the mass as plasma glucose. When cycling at 75% VO2 peak, your plasma glucose pool eventually will drop. We have labeled our inflow as the exogenous glucose solution and outflow as the ATP utilized at 75% VO2 peak. The outflow remains constant during exercise at 75% VO2 peak. When ingesting a glucose solution during exercise, the subject is increasing the inflow. As outflow stays at a constant rate, the increase in inflow will increase the mass. This system adheres to theories regarding conservation of mass.
During exercise at high intensity, your body is using blood glucose at a constant rate to meet energy needs. When you have no glucose ingestion, i.e. no increase in plasma glucose during exercise, the rate of glucose utilization is maintained, therefore the level of blood glucose gradually decreases until time of exhaustion. With glucose ingestion during exercise, we see an increase in blood glucose, therefore levels of glucose do not start decreasing right away, and beginning levels are maintained for a period of time, and then start to decrease at the normal constant rate. Therefore, we hypothesize that time to fatigue is delayed and you can maintain exercise longer with ingestion of glucose during exercise. It is important to note that there are other sources of inflow that may alter levels of plasma glucose during exercise. These alternate sources of inflow include muscle glycogen stores and hepatic glycogen stores. As these sources are not affected by changes in exogenous glucose in the form of a glucose solution, it is not pertinent to our hypothesis. Therefore, we will not investigate mechanisms that alter muscle or hepatic glycogen stores.
Our hypothesis is backed up by a study done by Wright, Sherman, and Dernbach. They looked at 9 cyclists cycling at 70% VO2 max until time to exhaustion. When they compared an exogenous source of glucose with no exogenous source of glucose during exercise, they found that blood glucose was increased by 49% and maintained during the first hour of exercise and then gradually decreased. With no exogenous glucose, the rate of blood glucose started to decrease immediately. It was also demonstrated that at the time to exhaustion, the concentration of blood glucose was the same in both trials. From this, it is important to note that the rate of decrease in plasma glucose is constant between both trials. However, with the ingestion of exogenous glucose during exercise, the onset of decrease occurs at a later time. This study demonstrated a delayed onset of fatigue with exogenous glucose ingestion during exercise. These results can therefore validate our hypothesis.
She got 99 problems, but blood glucose ate one. In conclusion, if a subject ingests a glucose solution, they will increase their pool of plasma glucose, and that increases the time to fatigue. However, this is only pertinent as comparing to a subject with water and if they're both cycling at 75% VO2 peak.